Alright, in this video, we are going to discuss something called recursion. Now, most of you are probably quite aware of what a loop is, right? For int I equals 0, I less than 5, I plus plus, and I simply just make a simple loop. And you see it'll print so many times. In this case, 0 to 5. Now, recursion is kind of like a loop, except with a method. It's actually vastly superior to loops in a lot of cases. Now, there's only a few places I'd really use recursion, but in those places, it is significantly better. Let's take sorting, for example. When you want to sort a bunch of numbers, we can use a loop and go through and move things back and forth, probably 2 or 3 loops, and we'll go in and sort and get everything sorted. And that'll work. The bigger the number, if we're using that particular kind of loop, the longer it's going to take. Now, if we use recursion, however, that time goes to fractions compared to what it would be normally if we were using just a big loop. Well, let me explain a little bit about what recursion is, and we'll make something here. Well, that was the explanation. Well, let's make a recursive method here. So what I'm going to do is I'm just going to make a public static int double factorial. I think int factorial will be fine. And I have to give it a number in, let's say. Now, end factorial. Now what a factorial is, as a little preface to this, if I was looking for, let's say, 4 factorial, what that would be is 4 times 3 times 2 times 1, which, if you did your math right, would be, well, let's check it out. 2 times 3 is 6, times 4 is 24, right? Now, if I did 5 factorial, it would be 5 times 4 times 3 times 2 times 1, which we multiply that, 120. You see it goes up pretty much exponentially or more, as we add another number. 6 factorial would be 6 times this. So basically 720, I think. So you can't really go up too big or you're going to really skyrocket and like break the bounds of what an integer can hold. But the way a factorial would work is I would give it the 5. And then it's going to call itself and start doing this math. And once it finishes, it's going to return back, and I'm going to get the answer. Now that sounds a little funky, but let me write it out first. Now there are 2 states here. State 1, if n is 1. If n is 1, I'm going to return 1. This is what's called as the base case, or the end case, you can say. So what I'm going to do is I'm going to subtract 1 every single time I do this. And once I get to 1, I'm at the end. I can't subtract anything else. So that's what's going to happen here. Now, if it's not 1, what I'm going to do is I'm going to say return factorial n minus 1. Actually, I'm sorry. Let's see here. Return factorial n minus 1 is going to return 4. It's supposed to be n times. Return, there we go, n times. There we go. That's what I'm looking for. So, end if. This is it, basically. Now, let's run this and see if it puts up my numbers that I showed you. Then I'll explain how it works. So I'm going to come here and just say print factorial, and let's go with 4. That's that 24 we saw. So 24. We'll go to 5. That should be 120, right? 6, 720. And if I go up 7, you'll see that 720 quickly becomes 5,000, 8, 40,000, 9. If only my bank account would go up that quickly. 300,000. And once you start getting past 10, you get into, some big numbers. And it really doesn't take much, 19, to just downright get up to the point to where you're getting pretty close to exceeding the amount that you're allowed to go. 22, there we go. 21, yep, I broke it. 20, still broke it. 19. Because we're going up exponentially. So it'd be this 19 factorial will be 19 times 18 times 17 all the way back to 1. And that gets to be a pretty big number, as you can see. So let's explain what this is doing. I'm going to drop this back down to 4. Make this a little easier to read. Here's what this does. I passed the 4 in. So 4 is going to be right here. Now, if n equals 1, well, 4 is not 1, so it's going to do this else. It's going to return 4 times. And then we have this factorial. This is going to call factorial again. So basically, it's going to call the method inside of itself. It's going to run this again. So we're actually waiting for this return. So what we're going to have to do is we're going to come here, and I'm going to call that. And it's going to run this again. So it hasn't returned yet. It's got to run this first. We run this again, and I'm going to give it n minus 1, which n was 4. That means I'm going to give it 3. So we're going to run factorial 3 now. 3 is not 1. So this is going to return 3 times, I got to run factorial again, 2. We come up, 2. Well, 2 is not 1. Return factorial 2 times, or 2 times factorial 1. Now we're going to run up here. N is 1. Return 1. That's the end case there. That means 1's going to come back. Boom. 2's going to come back. 3, 4. And basically this little star is going to multiply each one of these. So what we end up getting here is actually 4 times 3 times 2 times 1. It's going to return that result, which would be 24. So this is what a recursive method does. Now, notice I didn't need any loops for this. Could I use a loop right here for this? Yes. For this, it's fairly easy. But I think if you actually time them, you probably would find that this is actually a little more efficient. Now, if we're dealing with super large problems, this will work infinitely better than a loop. And there's plenty of examples of that if you want to look up bubble sort versus merge sort or something like that. Those are sorting algorithms. One uses recursion and the other does not. And we're talking hours of difference in time if you're sorting like ginormous amounts of numbers. But this is your basic recursion. Now, as far as most programs we do in class, you won't really need to use it. I'm just showing you what it is so you can be familiar with it, because you're going to see it again, particularly if you're going to be doing more programming. Particularly higher level programming, there is a fair bit of recursive methods that are used because they're more efficient. Whether it's sorting numbers, whether it is, let's say, displaying graphics on the screen. If you have like a 3D graphic, it's probably better to recursively run and call everything, all the updates and everything, than it would be to have a simple loop just spitting it out on the screen every second. But that is recursion. Now you can try a couple of other examples, but like I said, you're not really going to be using this unless you're dealing with those specific problems at the moment. All right, hope you enjoyed that, and I will see you later.